Because that's what percent is, right? Look, here's all we just did. What's that mean? That means 62 miles over 1 hour. I can't do much with this, but now I have a conversion factor, dimensional analysis, all of the problem-solving skills from 111 that we're reinforcing now. Okay, so I need molarity. I know that molarity is not over there, but it's moles per liter. I don't care what you do first here, it doesn't matter at all. We can divide the 5 by the molecular weight, grams divided by molecular weight, that gets us moles, or we can fix the bottom. I generally fix the bottom first, so I'm going to change this to 50 grams over 1 liter. In other words, I multiplied 100 by 10 to change it to a liter, so I have to multiply the top by 10, so now I've got 50 grams over a liter. So my bottom's where I want it in terms of molarity. Now I'm back to that number of grams divided by molecular weight gives me number of moles. So 50 divided by what's the molecular weight? 180. Divided by 180 is 0.278, and there's a lot of other decimal places out there that I don't see. That's 0.278 and change moles per liter. Moles per liter. That's what I want, isn't it? So it's 0.278 molarity. It's glucose. I've got my molarity. What's my Oz factor? So it's 0.278 osmolarity. And then my milli. So listen carefully. Listen very, very carefully here. Calculators work with thousands or tens of thousands of decimal places. You don't get to see it. You might see 9. If your calculator allows you to tell it how many decimal places you wish to see, you've probably told, well, first of all, you probably don't know how to do that because it's like programming a VCR. Be honest, who's ever read the owner's manual for their calculator? I know who has. Those of you that have had Math 121 college algebra and had to learn how to use the graphing calculator. You bet you read the owner's manual. Yeah, or you didn't make it through the class. Or you went to the math lab and let somebody explain it to you. But most people don't know anything about how to tell the calculator, I want to see 2 decimal places. Now I'd like to see 3. So they see whatever the default is. And the default is often 2, because we use them for dollars and cents more than anything. Or the default is however many there are, but it'll only go out to 9. But the thing's working with thousands and thousands of decimal places. So when I say this is 0.278 and change, all I see is 0.278. I can tell it to show me more, but I don't care what's out there. But I want the calculator to use all of those decimal places because they're there. If I were to, and I don't know why anybody would do this, but if I were to clear my calculator and re-enter 0.278, I would not be working with the proper number because the number is 0.278 and 1,000 more decimal places that I can't see. So don't ever, ever clear a calculator until you reach your final answer. And don't ever quit using a calculator when you start using it. Even though all I have to do here is multiply this by 1,000, I'm going to let the calculator do it for me. It probably won't matter. 99 times out of 100, it won't matter. But you never know. You never know the one time it might matter. How many of you use Excel? Do you think that Excel rounds in between? It only rounds when it gets to the final answer. It doesn't round in between. So you don't ever round intermediate answers. And if I quit using my calculator, I am effectively rounding. So I'm actually going to say times 1,000 equals. Again, it's probably not going to matter, but I don't know whether or not it will matter. 277.778. Well, if I want that to 2 decimal places, I'd have 277.78. If I just move my decimal place over 3 places here, I'd have 278. That makes sense because if I round this to 1 decimal place, 277.8, if I round it to no decimal places, I'd have 278. But what if your instructions are to round to 2 decimal places? You didn't do it. Is that right? No. So I repeat. Don't ever round an intermediate answer. If you start using a calculator, use it until you're through with the problem, even if it seems as simple as doubling or moving the decimal place. This will save you points. All right, we didn't get 290, but why is the number okay?
Because it's
Within the clinical range. Could they create a glucose solution that was dead on 290? Of course they could, but it'd be 5.086% or something crazy, which would cost more to manufacture. It's all about the almighty dollar. Your health is irrelevant, says the insurance company. The almighty dollar is what matters. So therefore you can't have that MRI. We'll just use the X-ray and hope it's accurate. That is the world you live in. Nurse's line. Yes, this is King Super. I have John Doe here trying to fill a prescription for blah, and his insurance company doesn't cover that. They're wondering if the doctor would be comfortable with blah, blah, blah instead of blah. Well, let me ask Dr. X and I'll get back to you. That's the world we live in. We expand it. And so here we go. Doesn't matter what you do first, convert the grams to moles or change the mils to 1,000. I always change the mils to 1,000 first. It's just my habit. Doesn't mean you have to do it that way. It does not matter. 8.5 grams over a liter. So now I divide by the molecular weight. Remember, sodium chloride and glucose are the two where we don't calculate molecular weights. We just know what they are. They're on your flashcard from Monday. So 8.5 divided by 58.5. .145 moles per liter. So that's 0.145 molar. What's next? Multiply it by 2. Why multiply it by 2? Oz? Sure it doesn't matter, but I'm going to let the calculator do it for me. 0.291 osmolarity. See, I wouldn't have picked up that 1 had I doubled this in my head. Does that 1 matter? I don't know. But it's the real number. Start with a calculator, finish with a calculator. What's the last thing to do? Multiply it by 1,000. 290.598 milliosmolarity. Boy, that's well within the clinical range, isn't it? We nailed that one. So 291 we could say if we wanted a whole number. So that is why you go see your friend in the hospital, you look at their IV. I'm not talking about the morphine or the antibiotics, but the main line going in is going to say saline, 0.85% sodium chloride, or glucose, or dextrose, or D5W. That's the isotonic solution. Anything else going into the patient can be fed in through that line. All right, we're out of time, but before we go, I'm going to just let you know what's next, so you can read about it. Molarity, moles of solute for 1 liter solution versus molality, moles of solute per 1 kilogram solvent. God, they look different. This is a solution. This is a solvent. We talked about that on Monday. Man, this is a volume. This is a mass. Oh my God. Scary stuff. These, of course, are the same. The numerator is the same. As we'll see on Monday, the difference between these two, when the solvent is water, is insignificant. Once again, we're glad we deal only with the chemistry for physiology. If we worked in a lab and we were trying to develop some new super strong, super light plastic, and we were working with benzene and toluene and acetone and all of the organic solvents, these would be as different as a dog and a cat. But for us, these are nearly identical. So that's where we will pick up on Monday. Please remember, next week there are no labs because there's no class on Monday. There's no class on Monday, yeah. So when I said Monday, what did I mean? Wednesday. So next week there are no labs because there's no class on Monday. We're not going to have a lab on Wednesday when we couldn't have it on Monday. So you have no classes on Monday or Tuesday. That is not just me or the Health and Science Division. That is school-wide. As far as I know, the campus will be open on Tuesday. So if you have other things, they might be available.